Okay, we're going to start with lesson one, basics. What is a rational number? There's different levels of it here, so we're going to start with what's known as natural numbers. These are known as counting numbers. Basically, how we start, we got one, two, three. The dot, dot, dots mean we go on forever to infinity. Whole numbers, what we basically do is we add in the extra zero because we need that in math. So then we move on to integer. Integers handle all the positives and negatives, so the dot, dot, dot on the left applies to the negative infinity, and the dot, dot, dot on the right goes to positive infinity. Then we move down to rational. This is anything that can be expressed as a fraction. So any number like 5. 5 can be expressed as a fraction because it's like 5 over 1. The only restriction here is b cannot be equal to 0 because we cannot divide by 0. So here's some examples here, and you can see uh, like 4. 4 over 1, yep, that's a rational. 1 over 3, it's already in fraction form, that's a rational. 0.2 is a decimal, but we can convert it to a fraction. 2 over 10, which reduces down to 1/5, that's also a rational. 0.6 repeater. Now that number goes on forever, but it can be expressed as a fraction, 2/3, and the other one that kind of goes with it is 0.3 repeater, which is 1/3. Okay. So then we have the other one is everything that's irrational, and that means non-repeating, non-terminating. So pi, that goes on forever, but there's no repeating at all. Square root of 2 goes on forever, no repeating. Square root of 3. Now, what about the square root of 4? Well, no, that's not irrational because the square root of 4 is 2, which would make it a rational number. Now, all of these together form what's called real numbers. So all of these things, from natural, whole, integer, rational, irrational, are all real numbers. All right, next page. So what we can do is we can talk about whether or not you can place numbers on a number line. So what we have is here is we have a bunch of numbers, and if you look, oh boy, they're kind of crazy. So we got some fractions here, we got some whole numbers. You can even deal with decimals. What you have to get used to is converting them to either like 1/2, either figure out where that is on a number line, or convert it to a decimal like 0.5. So what we have here down is a number line, and you can see how we've placed them. So A somewhere in here, right? B over here because it's right on the 2. C is 3/4, so you already have A here at 1/2 and the 1 here, so you can cut it in between there. D, 5 over 2, which can convert down to 2.5. E, negative 1/3, so we're on the left-hand side of the number line. Negative 1/2 for F, right here. G, negative 5 over 4, which is negative 1.25. H, negative 0.8. So if you're looking here, that's pretty close to negative 1. I, negative 2.1, which is just past the negative 2. Remember, going over here, numbers are smaller. J, negative 4 over 2, which is negative 2, so we can put it right on the line there. Okay. So then we have some more down here. Placing these numbers on a number line. So we have negative 3/8, positive 5/9, negative 10 over 4. Now, and negative 1.25. You could break it up into different ones, or you're trying to use your best guess or best estimate of where they are. Like negative 3/8 is between 0 and negative 1. Negative 4 over 8 would be half, so that would be in the middle here, so it's just a little bit to the side of it. 5/9 is just a little bit greater than 1/2 between the 0 and the 1, so you'd probably put it about there. Negative 10 over 4 can be converted down to negative 2 and over then 2/4. Reduce it one more time, negative 2.5. Then you would put it over here, negative 2.5. And you could either write the negative 2.5 or the negative 10 over 4, depending on how you want to write it. And the last one, negative 1.25. You could split up, right? This would be negative 1.5, so then negative 1.25. Okay, last page. So what we got is we can talk about which numbers are equivalent or equal. So we got a bunch of numbers here, and what I do is when I teach this, I kind of show students, I like to circle things or make boxes around things showing equivalent numbers. So if you look here, we got a circle around here. There's negative 1 on the top and 4 on the bottom. Well, that's the same as 1 and negative 4 on the bottom because they're both negative 1/4. Here, these ones with the squiggly lines around them, this is positive 1/4. And we know from past experience that a negative divided by a negative right here is also a positive. So these two are equivalent. Here, 4 over 1, again, positive. 4 over positive 1 is still a positive number. Negative 4 divided by negative 1 is still a positive number. So these two are the same. And this lone one here is just kind of by itself. So what can happen then is, we can look at these things and I could say to you then, we got 3 quarters, 3 quarters, 3 quarters, and they all have negatives. So negative 3 over 4, 3 over negative 4, and negative 3 quarters. Well, these are all the same. They're all equivalent fractions. You can write it on the top, the negative, or on the bottom, but we normally write it in the middle. And then last thing here, we have some symbols. This is all good for rational numbers, just so you can do the first exercise. Uh, what we have here is we have the basic ones. Some of you might have remember as alligators eating the bigger number, or like a Pac-Man. So this is less than or equal to, greater than or greater than or equal to. Okay, so now what you can do is you can go over to lesson 1. You can do the exercise that goes with it.